Hello, fellow art programmers. Welcome to the sixth session of Social Informatics. Today we continue our discussion about R-type system and structures. In continuation of what we learned together about R, that was finding or retrieving specific rows and columns of a matrix. In this slide, we are gonna follow the same topic, and based on that, we are gonna learn more about how to access elements of a matrix, but this time through the row and column names. This approach is very common because we are going to do it also with tables a lot. And since so far you should have learned about the logic of R programming, you now should have your own idea about accessing elements of a matrix through rows and columns names. Okay, so if we have this matrix, you see the rows names glory, pride, victory, and you see the columns names A, B, C. Okay, here at the bottom, it shows the syntax that we need. Okay, because here the rows have names. So when you want to retrieve or have access. Okay, you have this max. Okay, when you want to reach out to a specific element, as you learn it, you open brackets, and after that you go for a vector. Why you go for vector? Because here you are going for specific rows or columns. So here, which rows you are going for? Because it is the first part. The rows that you want to get, you should put the name here. As you can see here, it is here glory. So it's gonna get this row. What other rows? It asks for victory, so it gets this. So you see here, instead of putting the index, here it puts the name, the title of the rows or columns, and after that it goes for B and C because it is the name. The logic is the same as before, B and C. So now, what are the items that are called by rows and columns? We have these, we have these, we have these, and we have this. The same logic as the one we discussed together last week. So here we have 5, 4, 8, and 9. The only difference, instead of putting the index, you are putting the name. You may ask, it is much easier to use index. Why we need to put the names? Because it happens. Sometimes we don't know about the index and we just want to tell R, go to the column that has this name. And since it is obvious and we have done it with the previous examples, I'm not going to do it in R. So you please run it in R and please let me know if you have any question. And another point, please not just try to copy this command or syntaxes or formulas that you see in front of you. Just do some changes. For example, if you see here, it is glory. Okay, the next time you go for pride and victory, go for pride and glory. I mean, change the order and see what will happen. For example, if you put victory here and after that glory, what will happen? Okay, and here again change it. For example, here we have C, B, and C. Okay, and try to be B, C, B, and again see what will happen. Of course, I'm sure now you have gotten the logic and you already know what happens if you put B, C, B. But try them, and in that way, strengthen your knowledge and become more savvy or become savvier in R. Okay, let's know some of the helpful operators in R. All the operators in R are helpful, but these ones that I have brought for you here are very popular. We are going to review them together because gradually we need to learn some of the operators, because operators connect all the functions that we want to use in an algorithm to make an application out of that. Okay, the first operator that I have put for you here is double percentage. Double percentage gives a remainder in dividing. For example, when you put 4 double percentage 3 means gives you the remainder of if you divide 4 by 3. So when you divide 4 by 3, the remainder would be 1. Okay, it is, for example, if I want to tell you one application, one use of this command is that if you divide a number n, okay, over 2, if I show you this, for example, n double percentage 2 equal to 0. What do you get about n? You will notice n is an even number because the remainder of dividing it by 2 is 0. So you see, you can find many applications for these operators, okay? So double percentage. The other one is double equal. Double equal checks whether two objects are equal or not. For example, 4 equal 4 in fact checks if 4 is equal to 4. Since these two things are equal, so the results would be true, my friend. So if I put here, for example, 3 equal 10, the result would be false. Okay, exclamation mark equal is opposite of equal. So it checks if two things are equal, it checks if two things are not equal. They are operators that you will use in programming a lot. And after we review this page, I'm gonna run some of them for you in R so you may understand them better. Because when you are doing programming, checking these logical statements happens a lot. For example, you are checking if two things are equal. You are checking if two things are not equal. If you want to check if two things are not equal, you use exclamation equal. As you can see, check whether two objects are not equal. For example, 4 exclamation mark equal 4, it checks if two things are not equal. 4 equal to 4, so not equal is false. Okay, if you find it a little bit confusing or so much confusing, just stop the video, replay it, and try to work on that. See, for example, I put 3 equal to 10 is false because 3 is not equal to 10, but 3 is not equal to 10 is true. Okay, another things, we have colon. Colon generates ranges. For example, 1 colon 9 generates 1, 2, 3, 4, 5, and you would get it yourself for sure. For example, if you want to put some IDs for example, 1 million rows of data, it's not possible to put them with row names or you put them with column names. Very easily you can use colon, and for example you put the colon as like this, 1,000,000, 1, 2, for example 2 million. Okay, for doing this you can use colon. Another command we have, because it is not an operator, it is class. Class returns class of the object. These things like class, like str, you already know about str because in previous, I guess, video lectures I showed you about the structure of when I was explaining for you drop off command. Okay, so class, str, and summary are of the same type. They are very helpful commands that whatever you put inside the parentheses, they give you a report about that. Class gives its own report, str gives its own report, and summary gives its own report. As you can see here for class, it explains class, open and close parentheses, whatever you put here, returns class of the object. What is the object? Object is something that you put here. For example, for str, you remember our object was matrix and also a vector. So you put your object inside str. str is a compact way to display the structure of an R object. You see, all of them are talking about this object. Summary is a generic function used to produce result summaries. Okay, so you put any objects here, and based on some predefined instructions, they give you some reports. And again, all these things are part of that wonderful thing about R that provide statisticians and data analyzers with so much support. But another operator or command here is T, that when you put a matrix or table inside it, so when your object is a matrix, okay, or when your object is a table, when you put it here, it transposes it. And when we are doing data analytics projects, it could be very helpful. What is transpose? Exactly the same thing that we have with transpose in Excel. The same we have at the transpose we learn at the general mathematics class at university, or the transpose we learn in high school. If I want to give you a simple example, see, when you have a matrix that is size of, for example, 2 times 3, the transpose make it size of 3 times 2. If you have a matrix that is size of 1 times 4, when you transpose it, it makes it 4 by 1. If you transpose a transposed one, you get the original one because it's gonna get 1, 4. Here you can see the result. Another example, we have mat 2, and here is the matrix. Please do all these things on your R, and if you encounter any problem or question or issue, quickly reach out to me. So when it put T inside the parentheses would be the object, so it transposes it. What happens now? Here the size is 3 times 2. Here we have the size 2 times 3. Anything here that we have that is row, here become a column. Anything that here we have as column, here we have it as a row. So you see, it would be very helpful that when you are working with matrices of big sizes. So here we have 1, 2 as a first row. Here 1, 2 is a first column. 3, 4 is a second row. Here we have its second column, and like that. And for example, 2, 4, 6 here is the second column, but here we have it as the second row. Practice them in your R.